Okay, let's dive right into this. Welcome to today's Explainer, where we're going to unpack one of the most fascinating journeys in modern manufacturing. Have you ever wondered exactly how that sleek, powerful machine sitting in your driveway actually comes to life? I mean, the automobile is just an incredible engineering feat that has completely transformed the way we travel. Manufacturers have been refining this process ever since Henry Ford revolutionized the assembly line. But today, the design and material use have become incredibly intricate. So we're going to trace the birth of a car, taking it all the way from a digital blueprint on a computer screen to a physical road-ready vehicle. To do this, we'll follow a clear five-stage blueprint. We're going to start with design and prototyping, move into the heavy machinery of stamping and welding, explore the precise chemical engineering of the painting process, travel down the final assembly line, and finally wrap up with rigorous quality control and launch. Let's kick things off with Phase 1, design and prototyping. Long before any metal is bent or a single robot is powered on, a car is literally born in the minds of designers and engineers. They collaborate to create concepts that balance aesthetics, functionality, and cutting-edge technology. And they aren't just using pen and paper anymore, right? They rely heavily on highly advanced computer-aided design, or CAD software, and virtual reality tools to fine-tune every single contour. Now, the timeline for this is kind of staggering. It typically takes anywhere from 2 to 5 years to make a car from start to finish. It starts at year 0 with market research to respond to exactly what the public needs. Then it moves through extensive CAD modeling in year 1, hits physical prototyping around year 3, and only reaches the market by year 5. This massive, multi-year process is absolutely essential. It ensures the vehicle is completely sound and safe for public use, while also giving the team time to develop innovative designs that will actually spark interest in a super crowded market. So what's really interesting here is exactly what happens during that prototype testing phase. They build small 2D and 3D models specifically to put the design through the ringer. Engineers are rigorously testing for aerodynamics, verifying safety features, and simulating extreme hot and cold weather conditions. They're also calculating fuel economy, checking the electrical functionality, and running strict cost analyses. All of this has to be approved before a single piece of the actual production car is manufactured. Once those specs are finally approved, we transition to the factory floor for Phase 2, stamping and welding. This is where the heavy industrial magic really begins. The first step involves gathering the raw materials. And what's really notable today is that manufacturers are increasingly prioritizing materials that are sustainable, lightweight, and cost-effective to meet the growing demand for greener products. So, how do those raw materials transform? Well, it starts with the stamping process. Raw metal sheets are fed into high-pressure machines using massive molds and dies to actually shape the bodywork, creating the side frames, doors, hoods, and roofs. Once they're stamped, these parts are passed to the welding phase. Here, robotic work cells often work entirely on their own to join these pieces together. The most widely used method is called spot welding, where the metal is locally heated and pressurized to create a complete structural car body assembly. And this brilliantly illustrates the sheer strength required in this process. Just think about this number: 5 kilonewtons. A single car body typically requires several thousand individual spot welds. Every single one of those weld points must meet extremely high strength requirements, capable of withstanding up to 5 kilonewtons of tensile force. To put that into perspective, the bond is so incredibly strong that if it were subjected to extreme force, the actual steel sheet would tear apart before the weld point itself breaks. No way, right? It's literally stronger than the steel itself. With the structural frame fully welded and rock solid, we move into Phase 3, the painting process. Now, it's easy to think of painting as just the fun step that makes the car look sleek for the showroom. And sure, it does enhance the appearance, but it plays a much more vital role. This is a highly complex, chemically precise process that takes place in strict clean room paint shop operations. Why? Because it's the primary defense to protect the metal against corrosion, scratches, and the elements. Let's see how this builds across a strict 4-stage chemical sequence. Step 1 is a rigorous pre-treatment and cleaning to remove any debris or factory contaminants. You need a completely blank slate. Step 2 applies a critical primer coating. Step 3 utilizes advanced automated spraying systems for the actual color. And Step 4 is the drying and curing phase. This entire sequence requires a massive amount of chemical treatments and incredibly precise control of process parameters. The demands on both the paint materials and the automated equipment here are absolutely off the charts. After the fresh paint is dried and gleaming, the car body enters phase 4, the final assembly line. This is an absolute marvel of logistics. The final assembly line is a highly integrated mechanical production system. It relies on moving process chains, specifically the trim and chassis assembly lines, driven by multiple motors, body conveyor lines, storage lines, and specialized equipment designed for lifting, turning, pressing, and bolting everything together. The assembly workshop is typically divided up into major modules. You've got the front assembly, the dashboard and interior assembly, the headlight assembly, and the chassis assembly. This is where human technicians and robotic arms work side by side. Skilled workers carefully install the dashboard components, the seats, infotainment systems, air conditioning, and all those interior trim pieces that make sure you're comfortable on your drive. So, the absolutely crucial point here is what industry insiders call the marriage. See, while the main body was being stamped, welded, and painted, the powertrain, the engine, transmission, axles, and exhaust systems was being assembled completely separately. The marriage is that monumental moment on the assembly line where this completed powertrain is finally lifted and installed into the main vehicle frame. Technicians connect all the complex wiring and hoses to ensure that the mechanical heart of the car functions perfectly with its body. Then, the tires are furnished so the car can finally stand on its own 4 wheels. But hey, the car isn't ready for the dealership just yet. That brings us to our final stage, Phase 5, Quality Control and Launch. This is the ultimate, rigorous hurdle to ensure that every single mechanical, electrical, and safety feature is absolutely perfect. Any imperfections or inconsistencies in the interior or exterior design are flagged right here. Right off the assembly line, the car undergoes what we can think of as rapid-fire DMV-style tests. Before it goes anywhere, technicians perform multiple engine start and stop cycles. They adjust the steering and wheel alignments, meticulously check the headlights for proper brightness and reach, and rigorously test the brakes for basic safety and drivability. They also verify the car's programming and electrical units for safety and accessibility. It's essentially a massive final exam for the vehicle. Then come the extreme tests, providing a pretty stark contrast in what is being evaluated. On one hand, we have heavy water testing, where the car is subjected to intense water pressure to uncover even the tiniest hidden leaks in the weather seals. On the other hand, we have crash testing, which is all about observing high-impact physical destruction. The manufacturer executes real-world crashes to observe how the car handles impacts, verifying that the airbags and seatbelts perform exactly as designed to protect you, the passenger. If a car passes all these tests and requires no further tweaks, it's finally cleaned, prepared for shipping, and sent to dealerships. But I want to pause on a really insightful point from our source material. It says, the differences in quality across different car models often come down to the management systems and quality control within the company. And that's a great reminder, right? We just explored an incredible array of advanced robotics, high-pressure stamping, and automated clean rooms. Yet, at the end of the day, any mistake in these processes impacts the final vehicle. It's the human element, the management, and the people running the quality control that ultimately dictates the true quality of the cars produced. And that brings us to the end of our manufacturing tour. We've covered a massive amount of ground today. So I'll leave you with this question. After witnessing the staggering 2 to 5 year journey from a digital blueprint to 5 kilonewton robotic welds that are literally stronger than steel, all the way to extreme heavy water and crash tests, how will you look at your daily commute differently? Millions of us rely on these machines every single day. The next time you sit behind the wheel and turn the key, take a moment to appreciate the immense, brilliant engineering feats sitting right there in your driveway. Thanks for joining me for this explainer, and keep exploring how the world around you is made.